with looking at this Unit 4 test review. And just to give you a heads up, I'm going to go through each problem and do it fairly quickly and explain it as I go, because this is assuming you've already tried them yourself, and so this is just to catch errors. Alright, you'll see that the sign in between these two polynomials is subtraction. Now you can either distribute through the subtraction to get 2x cubed minus 4x squared minus 4 minus 9x cubed plus 5x to the 4th plus 4x squared minus 1. Or you can just remember that you're subtracting each term. And then at this point it's just adding and subtracting like terms. Excuse me. So I have 2x cubed terms. If I add those together I get negative 7x cubed. I have 1x to the 4th term. I'm going to put them in order here. I have 2x squared, but they actually end up canceling each other out completely because you have negative 4 and positive 4. Then I have negative 4 minus 1 to give me negative 5. So this should be your final answer. For number 2, this is a multiplication. So I'm going to set it up using the table method here. You can use whatever method you want. Okay, so you should get 6x to the 5th minus 12x to the 4th plus 21x cubed minus 6x squared minus 6x to the 4th, 12x to the 30th minus 21x plus 6x. Your diagonals, oops, this should be x squared, are your like terms. So your final answer should be 6x to the 5th minus 18x to the 4th plus 33x cubed minus 27x squared plus 6x. So no matter how you multiply them together, that is what you should get. Okay, for number 3, we are just actually factoring number 3 and 4 here. This one is a difference of cubes. So keep in mind that when you're looking for a pattern or to factor, if you have two terms, really the only way that you can factor that is by using a pattern. And if you have a cube, then it's either the difference of cubes or the sum of cubes. If you have a difference, then it has to be the difference of squares. If this was a plus and this was a cube, if this was a plus and this was still a 4th, you would not be able to use a factoring pattern. You probably could not factor that one actually. So we're going to factor this one. The factoring pattern for the difference of cubes that you do have to have memorized was that right there. The a and the b are the cube root of both terms. So you have 3x and 4. And then you just put it into the pattern. So you should have 3x minus 4. 3x squared is 9x squared. A times b would be 12x, and b squared is 16. On the bottom here, this would be the difference of squares pattern if we're able to take the square root of the first and the last. Now in this case I can take the square root of 16, I can take the square root of 81. But let's say I couldn't, but this was still a difference. You could try pulling out the greatest common factor to see if that would make it a difference of squares, because sometimes that happens. But in this case we don't have to worry about that. So in this case, your a and your b are now the square root of both of those. And for difference of squares, that's your factoring pattern. So you have 4x squared minus 9 times 4x squared plus 9. And with polynomials, you just have to double check to see if you've factored as completely as possible. And in this case, actually, we have another difference of squares. So I can factor that one more step down to 2x minus 3, 2x plus 3, and 4x squared plus 9. That is what I would expect to see. Okay, flip it. So this one kind of looks like a quadratic because it's got 3 terms. So we're going to actually factor it like a quadratic. In this case, I hope you recognize that we do have a greatest common factor of 2 that we can pull out. I'm going to do that because it's going to make my numbers smaller and a little bit easier to work with. You'll also notice that I have an equal to 0, which means I'm going to be solving this. So, if I factor, because now I don't have a number in front of x to the fourth, I can start by figuring out what times what gives me x to the fourth, which in this case is x squared. What times what gives me positive 4 but adds to get negative 4? That would be negative 2 and negative 2. And then you take each factor and set it equal to 0. The 2 you ignore because it doesn't make sense to set 2 equal to 0. Then we set x squared minus 2 equal to 0. And get x equals plus or minus the square root of 2. Because these end up being the same parenthesis, we actually end up getting two double roots here. So you're going to get positive square root of 2 twice and negative square root of 2 twice, which you should have 4 answers, and by putting that dr there, you do end up getting those 4 answers. Okay. Last factoring pattern that we talked about was when we have 4 terms, you have to factor by grouping. So throw my parentheses up there. Pull out the greatest common factor in each case. I can pull out a 4x squared, and I get x minus 4. Pull out a negative 9. I get an x minus 4. So you get 4x squared minus 9 times x minus 4. Hopefully you recognize, because we just did it, that that is a difference in squares. So you can take that one more step into that scenario. And then if we set each one of these equal to 0 to get our answers, we're going to get 3 halves, negative 3 halves, and 4. We should have 3 answers because I started with a cubic. Alright, divide using long division. Let's set it up. Okay. You start by asking yourself the question, what times x squared gives me 7x cubed? Well, the answer to that question is 7x. You can't forget about the 1, so to take care of that 1, to divide it in, you take the 7x, multiply it by the 1, and then line it up like term. You'll notice that we need a placeholder for x squared. And we subtract. 7x cubes cancel. Negative 4 minus 0 gives me negative 4x squared. 3 minus 7 gives me negative 4x. Drop down the negative 2. Then you go back up to the top. What times x squared gives me negative 4x squared? The answer to that is negative 4. And then to take care of the 1, you take negative 4 and multiply it by 1 to get negative 4. So again, we need a placeholder. Those cancel. Negative 2 minus negative 4 gives me positive 2. Negative 4 minus 8 gives me negative 12x. This is my remainder. So your answer here should be 7x minus 4 plus negative 12x plus 2 over x squared plus 1. Okay. Synthetic division. You can only use synthetic division when your divisor is in the form x plus a number or x minus a number. In this case, it's x plus, so our c value is actually negative 2, because it has to be able to be written in this form here. So in order to have x plus 2, I'd have to have x minus a negative 2. So that c is negative 2. Now, if you are missing any terms, like here we're missing the x squared, you need to make sure you put in a 0 for that. Drop down the 5. Negative 2 times 5 gives me negative 10. Add. Negative 2 times negative 10 gives me positive 20. Add. Negative 2 times 14 gives me negative 28. Add. That last number is your remainder, and then it goes up from there. So this is my constant, this is my x term, this is my x squared. So you should have 5x squared minus 10x plus 14 plus negative 27 over x plus 2. Okay. For this problem here, we have a rectangular house with a flat roof, and it has a volume of 609 cubic yards. The dimensions are x yards high, 12x minus 29 yards wide, and 12x minus 7 yards long. What would the dimensions be? Because I have a rectangular house, and volume is always the height times the area of the base, then I know my volume formula in this case is height and the area of the base. So if my base is a rectangle, then it would be length times width. So we're going to set up my equation just in that format. I know my volume is 609. I know my height is x. I know my length is 12x minus 7. I know my width is 12x minus 29. And then because I have an equal sign, now I know I'm going to have to solve. In order to solve, I need to get everything over to one side and get it equal to 0, and then factor. So we're going to have to simplify this part by multiplying or foiling together. I'm going to distribute the x through just that first parenthesis, and then I'm going to FOIL. Here we go. 12x squared times 12x gives me 144x cubed. 12x squared times 29 gives me negative 348. And then negative 7x times 12 is negative 84. So my outer and my inner, if I add negative 84 and negative 348, I end up getting negative 432 x squared. And then my last term is 7 times 29, which is 203. And then I'm going to subtract 609 from both sides. Oh, that should have an x with it. And then I'm going to factor by grouping. Now I know these are big numbers, but we can assume that it's going to come out nicely. So let's even see if 432 can be divided by 144, which it can conveniently. 3 goes into it. So I can pull out a 144. X squared. I'm left with x minus 3. Then here I can pull out a 203 because 609 divided by 203 is actually 3. So pull out a 203. I'm left with x minus 3. So my factoring is 144 x squared plus 203 times x minus 3. Now in this case, I'm only going to get one answer of x equals 3. If I were to set both those equal to 0 and solve this one, you'd have to subtract the 203 and divide by 144 and then take the square root, which would give you imaginary numbers, because when you subtract the 203 it becomes a negative number. So when I set this equal to 0, I get a positive 3. That's my only x value that will work for this scenario. To find the dimension, since that's what I'm looking for, if x equals 3, that means my height is 3 yards. Then I have to plug 3 in here, so 36 minus 29 is 7 yards. Plug 3 in here, so 36 minus 7 gives me 31 yards. So those are my dimensions. Okay. For R2, we're supposed to graph this on a graphing calculator, use the calculator, find the x-intercepts, maximum values, and then make sure you draw what you see in your window. So, first step I would do is I would go to, try to put this in place so you can see it. I'm going to go to the y equals and put in my function. Okay. And then I'm going to go to my zoom, and I'm going to go to zoom standard, which basically just makes your window negative 10 to 10. Now, this is not a great picture. I can kind of see maybe that's the peak there, but it's really, really close, so I might want to adjust that. And then I can see that it loops down, but I can't see the valley. I can see 3 x-intercepts, so that's good. But let's go ahead and expand my window a little bit. Let's go up 10. Let's go down to negative 40. Okay, perfect. So that's a good picture. Now, if I had to copy that picture, I'd basically draw what I see as best I can and label my window. So I'll go from negative 10 to 10 here, from negative 40 to 20. Okay, so that just gives me, so I know what you're looking at on your screen. Now, if we go back to your graph here, I need to find the x-intercepts, and then I need to find the max points and the min points. Let's start with the x-intercepts. You go to second and calculate. We want the 0 because that's what the x-intercepts mean. So to find this first one, go left bound, hit enter, right bound, hit enter, guess. First one's going to be negative 1.3, comma 0. Then we find the next one. Left bound, right bound, enter. We get 2.3, comma 0. And then, excuse me, one more time. Left bound, right bound, yes. You get 7.02, comma 0. Okay, so those are my three x-intercepts. To find the max, go back to your calculate menu, and you're going to hit max. So you need to be somewhere to the left of the maximum point, somewhere to the right. Enter. You get 0.26, comma 10.26. And then find the minimum. Left bound, enter. Right bound, hit enter. Hit enter one more time, and you get a minimum of 5.07, comma negative 17.52. And now that's the information that I would, like, this information basically tells me on the test that you know how to use the tools on your calculator, which is what this standard pretty much asks you to do. Okay, we have 3 graphing problems that we're going to finish up with. I'm trying to finish this within 20 minutes, so I'm going to book it. Okay, leading coefficient test. This is an odd function. It has a positive leading coefficient, which means as it goes from right to left, or sorry, from left to right, it has to go up towards positive values because it's a odd function or an odd degree. And behaviors are going to be opposite of one another. Then we set this equal to 0. I'm going to pull out the greatest common factor because now I'm trying to factor this to solve, and you get that expression. You can't go any further with that, so now I'm going to set my two factors equal to 0. You get 2, and you get 0 as a double root. I'm going to mark those on my x-axis. Now, a double root has a special quality with a graph. At a double root, so at 0, my graph is just going to touch, but it's not going to go through the x-axis. So I can kind of see what this might look like. I know I have to come up towards from negative values towards the x-intercept. I'm going to bounce off of 0, and then somewhere between 0 and 2, I have to loop back up in order to come back through that last x-intercept. So in your table of values, you want the halfway point in between 0 and 2, which is 1. And we're going to plug that in to the original equation to get the y value to plot. So I know exactly how far down it has to loop down until it comes back up through the x-intercept. If I plug in 1 up here, I get 3 minus 6, or negative 3. So I'm going to plot that. And then that gives me enough to graph. I'm going to come up, bounce off 0, come back down, and then come back up. Okay, so this example was refreshing our memory that with a 0 double root, or really any double root, when you get an answer twice, the graph just bounces there. It doesn't go through the x-intercept. Okay, two examples. For number 2, this is an even function, which means the end behavior is the same because it's a positive leading coefficient. You're going to go up and up. We're going to factor this just like we would a quadratic because there's 3 terms. So you have x squared. The two numbers that multiply to get 8 and add to get negative 6 would be negative 4 and negative 2. That x squared minus 4 factors down one more time. So I have 2, negative 2, and plus or minus the square root of 2, because if I set that equal to 0 and take the square root of both sides, I would end up getting plus or minus square root of 2, which as a decimal, because we're probably going to want to use the decimal version, is 1.4. Okay, so we're going to plot those. Now to make it a little bit easier to see, I'm going to make my x scale 0.5. So when I plot 2, I'm actually going to go 4 spaces, plotting -2, 4 spaces, positive 1.4, negative 1.4. Alright, now with this one, because your end behavior is both going up and up, and you have no double roots, that means you're going to be coming down like this. You have to loop, you have to loop, you have to loop one last time. So we actually have 3 turning points. We have this loop, we have this loop, and we have this loop down here. So we're going to find the middle spot between -2 and -1.4, between positive 1.4 and positive 2, and between 2 and positive 1.4 and negative 1.4. So to figure out the middle value, I'm going to add -2 plus -1.4 and divide by 2. I'm basically finding the average. So -1.7, which means the halfway in between point between 1.4 and 2 is positive 1.7. Halfway point between -1.4 and 1.4 is 0. And then I'm going to plug each one of these back into this function up here. I'm going to do that with my calculator by using the table feature. Oh, sorry, that should be x squared. Ooh, hopefully that didn't throw you guys off. Ouch. So -1.7, positive 1.7, and 0. So I plug in 0, get 8, and these are decimals, but -0.9, -0.9. Alright. So 0, 8, 1, 2, 3, 4, 5, 6, 7, 8. -1.7, -0.9. Positive 1.7. Right there. -0.9. And then you connect your dots. Alright. Last problem. This one looks like a sum of cubes. It is a cubic. Leading coefficient is positive. So my end behavior is going to be opposite, but it's going to be heading up towards positive values on the right-hand side. When I factor this, I'm going to have to use the sum of cubes pattern here, which is a plus b times a squared minus ab plus b squared. My a is 2x, my b is 1. So you get 2x plus 1 times 4x squared minus 2x plus 1. And then you set each one of these equal to 0. Well, we know from experience that if I set it equal to 0, I have to use the quadratic formula. That's going to give me a imaginary number. So I'm just going to ignore that one. I'm just going to set 2x plus 1 equal to 0, which if I do that, I get -1/2. My x is going to be 0.5 again. So -1/2 is going to be right there. Oops, sorry. Right there. No. Sorry. Ignore that one. -0.5. I got distracted by something. Because I only have one x-intercept, I need at least 2 other values to plot. And so we're going to pick a nice value to the left, to the right of -0.5, which would be -1, or 0. If I plug in -1 up here, -1 cubed is negative. So -1 times 8 is -8 plus 1 gives me 7. Sorry, -7. And if I plug in 0, I get 1. So we're going to plot those 2 points. So -1, -7, 1, 2, 3, 4, 5, 6, 7, 0, 1. And then there's just a slight curvature. And that's what your graph would end up looking like. I will be here tomorrow morning early if you need to come in and work with me. Or tomorrow after school if you're taking this test on Thursday. Just give you a heads up.